All right, y'all, today we are going to learn how to write the equation of a linear function and an exponential function from a table. So I'm pretty sure y'all have learned how to do this with a linear equation, but let's go ahead and just like remind ourselves of what this looks like. So writing the equation of a function from a table. This first table is linear. We found that out last class. How do we know it's linear? Because these y values are changing by a constant plus 2 each time. The way that we figure that out is we do 1 minus negative 1, 1 minus negative 1 equals 2. Then we do 3 minus 1, 3 minus 1 equals 2. No matter what, 5 minus 3, 7 minus 5, we will get 2. They're changing constantly. So that's why it's linear. Now let's remind ourselves of how to write a linear equation. So here we go. Here is a basic linear equation. And like I said, this is review, or it should be. Linear equations can be written like this: y equals mx plus b. Okay, and we need to make sure we know what m and what b are. X stays x. So what is m? M is the slope. And then what is b? B is the y-intercept. Cool. Now, we've talked about how when you see the word y-intercept, something super important should pop into your head. Y-intercept should make you think of one thing: x equals 0. That's what the words y-intercept should make you think of. So if we're trying to find the y-intercept in this table, sorry y'all, I don't know why my thing is freaking out. There we go. If we're trying to find the y-intercept in this table, we want to look to where x equals 0. So let's go to where x equals 0 in our table, and the y-intercept would be 3. So our b value for this function is 3. So let's go ahead and plug that in. For this table, we're going to write the equation y equals, we'll put m there in a second. We're going to put something for our slope, then we'll have x plus 3. Cool. So how do we know what to put for m? Well, if you recall, slope m equals change in y over change in x. It's rise over run. Now, for the tables that we're working with today, I made the change in x equal 1. What do I mean by that? These x's are increasing by 1 each time. These are increasing by 1, plus 1, plus 1, to get to the next one. So, really, our slope is just going to be this top part. It's going to be rise over 1, which would just be your rise or your change in y. Well, good news. Our change in y is right here for a linear function. So the slope for this equation is 2. M would be 2 for this function. So now you've written the equation y equals 2x plus 3. We have successfully written the equation of a linear function from the table for that function. All right, now let's try it for an exponential equation. So let's go down here. Again, this is from last class. We know that this function is exponential because we are multiplying to get our y values, to get each next y value. 1 times 3 gives me 3. 3 times 3 gives me 9. So we're multiplying to get to the next y values. All right, let's start in the same way. We need to write our basic exponential equation form. So an exponential equation looks like this. Y equals a times b to the x. And we're going to do the same thing. We're going to break down a and b. So a, in this case, is our y-intercept. And then b is going to be our multiplier. Sweet. So we have a y-intercept, we have a multiplier, and they're actually pretty easy to see from the table, just like before. The y-intercept, again, is where x equals 0. So for our y-intercept, we are going to go to the table and find where x equals 0. That's right here. So our y-intercept is 9. So this table's equation would look like y equals 9 for our y-intercept. Then we have parentheses to the x. The multiplier is the number that we multiply by each time for the exponential equation. So what are we multiplying by each time? 3. That is our multiplier. And now we have successfully written the equation of this exponential function from a table. Okay, so let's talk about a trickier version of this problem now. What if we can't see the y-intercept in the table? What if we can't see the y-intercept? So remember, the y-intercept was where x equals 0. Well, in this table, can we see anywhere where x equals 0? No. So what do? Well, we need to finish our table. We need to actually find the y-intercept. So here's what I'm going to do, y'all. I'm going to draw the table up here and pretend that we're kind of like going backwards in our table. So we have x equals 2. So the next x value would be 1 and then 0, right? If we're going backwards in our table. This is going to give us the y-intercept. That's going to give us the y-intercept. All right, and now let's just make sure we read, because I forgot to do that. Sorry. The following table represents an exponential function. So we know that the equation has to look like this. Y equals a times b to the x. Okay, we need the y-intercept. We also need the multiplier. Now, this one's kind of awkward. This problem is a little bit awkward because what if we do now? We can't really see our multiplier. Times, what do I multiply by to get from 12 to 9.6? Well, that's kind of awkward. So I'm also going to show you how to find the multiplier when you can't just like see it. So let's go back to our previous table to do that part. We're going to find the multiplier first. We're going to find the b value first. So let's go back to our previous table, and I'm going to show you how to find the multiplier if you can't easily see it. So here we know 1 times 3 gives me 3. We know that 3 times 3 gives me 9. What if I didn't know that? What if I couldn't see it? Well, good news. If you want to travel backwards in your table, you could just do the opposite of multiplication. Multiplication gets us to go down our table. It gets us to the higher x values. What if we wanted to go up in our table? So let's say we started with 81 and we wanted to get to this y value. What we're going to do is the opposite of multiplication because we're going the opposite of down. So we're going to divide. So check it out, y'all. We could get this value by doing 81 divided by 3. And that would give me 27. 27 is 81 divided by 3. What if I wanted to go from 27 to get this value? 27 divided by 3 gives me 9. See what I'm doing there? Okay, so how does this help us? Weren't we trying to find the multiplier before? Yes. Check this out, y'all. Your multiplier, write this down. Your multiplier can always be found like this. Multiplier equals the second y value divided by the first y value. Y'all, we can divide to find the multiplier. What do I mean by second y value and first y value? I'll show you. Here's the second y value, 3. So you'll put that on top, divided by your first y value. Ooh, those colors are clashy, so I'm going to change the color. Sorry, y'all. Divided by the first y value. So if we do 3 divided by 1 in this case it would be 3 divided by 1. We get 3. Wasn't that our multiplier? Yeah. You can always find the multiplier by doing the second y value divided by the first y value as long as you have an exponential function. All right? Okay, so let's do that now for this problem, and we'll find the y-intercept in a similar way. So let's find the multiplier first. Multiplier equals the second y value, 9.6, divided by the first y value, 12. That was the equation that we said. So let's make sure we remember that. It's the second y value divided by the first y value. So if we do that, let me get out my calculator. We're going to do 9.6 divided by 12. We get 0.8. The multiplier is your b value, right? So in this case, b equals 0.8. Let's go ahead and fill that part in of our equation. So y equals, we don't know a yet, but we do know b is 0.8, and then we have to the x. Now, to find a, we kind of already talked about it. Y'all, we want to go backwards in our table to find a. We've got to get to here. This is what we're trying to get, this y value. So if I want to find that y value and I want to go backwards in my table, what operation do I do? Well, to go forwards in my table, I multiply. So to go backwards in my table, I'm going to divide. Divide by what? Divide by your multiplier. So here we go. What we're going to do is to get this y value right here, we're going to do 12 divided by 9.6, or sorry, my multiplier, 0.8. So let's do that. 12 divided by 0.8. 12 divided by 0.8 equals 15. So the y value that goes here is 15. All right. What about to get, and sorry, y'all, 12 divided by 0.8. What about to get this, the actual y value we're looking for? You're going to do 15 divided by your multiplier, 0.8. And that will get you to that square. So let's do that. 15 divided by 0.8. 18.75. 18.75. That is my y-intercept. So that's what I'm going to put here. And of course, I didn't leave myself a lot of room. So let me, y equals 18.75 times 0.8 to the x. Here's the equation for this table. All right, if you want to see one more example, you can keep watching. Otherwise, that is all we learned, so you're probably ready to go. Let's talk about why this is useful and also do one more example. So, exponential functions can model a lot of real-world phenomena, like phone calls, for example. Since the year 2010, phone calls have increased. The number of phone calls that people make has increased. So, you can model it, the number of phone calls, using this exponential table. Now, we don't really know that this is exponential yet. It doesn't tell us that. It says write a function to model this data set. I know that it's exponential, but let me show you how to double check. How do we double check? First, I would do the test to check if it's linear. So I would do 4.81 minus 3.7, and then I would do 6.25 minus 4.81. See if you get the same numbers there. If you get the same numbers there, this table is linear. So let's try it. 4.81 minus 3.7. 1.11. So here we get 1.11. Now let's try the next one. 6.25 minus 4.81. Oh, I did 48.1. Hold on. 6.25 minus 4.81. 1.44. Okay, check it out, y'all. These numbers do not match. So this is not linear. If the function was linear, the change in y would always be the same for each change in x, as long as change in x is going up by 1, which it is here. 4, 5, 6, 7, 8. Those are just going up by 1. So this isn't linear. Now let's check if it's exponential. Remember how to find the multiplier. Multiplier, oops, let me write it over here. Multiplier would be the second y value, 4.81, divided by the first y value, 3.7. Let's try that. So 4.81 divided by 3.7, we get 1.3 equals 1.3. Now, how do I check that this actually is working? what I'm going to do is multiply by 1.3 to make sure that I get the right number as I go down my table. So let's do that. We already kind of did the 3.7, but we could start with that. So 3.7 times 1.3 equals 4.81. We got 4.81. Let's do the next one. You can't just go off of 1. You have to go to the next one. So let's do 4.81 times 1.3, which would be the multiplier, 6.253. Isn't that what we got? 6.253 shows up right here. So this is exponential, and the multiplier is 1.3. This is correct. Now we're ready to write our function almost. Let's write y equals, what's missing? A. Y'all, we don't know the starting value. We know x equals 4. We need to know, what about when x equals 0? So what am I going to do? Extend my table. And I know it's kind of weird that I'm adding this to the end, like the wrong end, but we can still use this end to visualize, right? So if we're going to go backwards in the x's, we go to 5, 4, 3, 2, 1, 0. And then we're going to have to find the y value where x equals 0 to find the y-intercept. Now, we know that that's the first thing in our equation. Let's go ahead and write the multiplier into our equation just to like feel like we're almost there. So y equals the multiplier raised to the x power. 1.3 goes in here. Now we just need our y-intercept. It looks like, the way that I drew this, looks like we're going down our table. So it looks like we would need to multiply, right? But we're not actually going down our table because we're going from x equals, or t, in this case it's t, right? But that's x, the same thing. T equals 4, and we're going to t equals 3. That's backwards. That's the opposite direction. So I'm actually going backwards in my table. What do I do when I go backwards? I divide by the multiplier. So here's what we're going to do. We are going to start with this y value, and we're going to divide it by the multiplier to get this y value. And we're going to keep doing that. So let's start with 3.7 and divide by the multiplier, 1.3. That gives me 2.846. This is like a long number, and I don't want to cut off any decimals. So here's what I'm going to do. I'm going to write 2.84 ... in my table. So I'm going to write 2.84 ... I'm not going to cut off any decimals. I'm not going to write 2.84 here. I'm just going to keep dividing by my multiplier to get the next value. So let's do divide by 1.3. See how I'm not like cutting off any decimals? I don't want to cut off. I don't want to round. Not yet. You don't round into the end. All right, so 2.18 ... So we get 2.18 ... right? Now we need to divide by 1.3 again. 1.68 ... 1.68. And we're almost to our y-intercept. We're going to divide by 1.3 one more time. 1.29. 1.29. And I'm allowed to round that one. I'll round that one. So my y-intercept is 1.29. This function models the real world number of phone calls in billions for each year since 2010. All right. That's the lesson for today, y'all. If it isn't making sense, make sure you ask questions. All right. Good work.